Good morning, everybody. Welcome to Natural Science Grade 8. I am Arifa Hafaji, and I'll be doing our lesson for today. Hope that you're all having a good day today. So yesterday we spoke about static electricity, and we'll recap on static electricity, and I'll also be explaining sparks, shocks, and earthing as well. I'll explain the purpose of an electroscope, and we'll do a concept map. And also, while I'm discussing sparks, shocks, and earthing, I'll also go over and just revise static electricity again because it still has to do with static electricity. So to recap yesterday's lesson, we learned that if two negatively charged objects were brought close together, then they would repel each other. And if two positively charged objects were brought close together, then they would also repel each other. Okay, if a positively charged object is brought near to a negatively charged object, they will attract each other. And so important for you to remember is that like charges repel and opposite charges attract. So the most important thing over here in the summary for you to remember is that like charges repel each other and opposite charges attract each other. So speaking about shocks, sparks, and earthing, a large build-up of a charge can be very dangerous. So we're saying basically a small charge, a small electric shock, like the one you feel when you pushing a trolley or on an escalator. Now that is not dangerous, but a large one can be very, very dangerous. Now, when electrons transfer from a charged object to a neutral object, we say that the charged objects are being discharged. So when electrons transfer from a charged object to a neutral object, we say that the object has a discharge of charges. So a discharge means that when a substance or material is released. Okay, so discharging can take place when the objects touch each other. So for example, you know, when you when you use the balloon and you rubbed it against your hair, so you used friction. So from the balloon, electrons went onto your hair, which caused your hair to rise. So this was the discharge of electrons because the balloon and your hair touched each other. But electrons can also transfer from one object when they are brought close together without touching. So that means that now the electrons, if they brought close together, like you can see in this picture I have at the bottom. So if these two objects are brought close together, but they're actually not touching, we can say that the electrons can transfer as well, right? It can move from one object to the other. And when the electrons cross over this air gap that you see here in the picture, they take heat. They can take heat they can heat the air enough to make it glow. So basically, the transfer of the electrons from this object to the other object heats the air and it makes the air glow. And you can see the spark here. So this spark here is actually the air glowing because the electrons have transferred from one object to another. So we call this glow a spark. Now, static electricity is an electrostatic charge. So another name would be ESD or short. You refer to it as ESD. So it's an electrostatic discharge. E, electro, S, static, and D, discharge. So a static electric spark is basically an electrostatic discharge. So I'm going to explain what this electrostatic discharge means. I'm going to define it for you. So an electrostatic discharge is basically a sudden flow of electric current across an air gap. So heating the air to high temperatures causes this glow. So another way of putting this is that basically the electrostatic discharge starts because of a sudden flow of electric currents across the air gap. Can you see? A sudden flow of electric currents across this air gap, and because the air is heated, it causes this glow. Now, the size of the spark depends on the separation of the sources of the electrical charges and their potential difference in voltage. So that means that the size of the spark basically depends on the separation of how far it is separated, or how close you bring the objects to bring it together. So then the voltage will increase if you bring the objects closer together, which means that the spark would be, you could see it more significantly. You could see it better. It would be brighter. So we're going to ask, you can ask yourself this question. Now, how does atoms become charged? So atoms become charged. Let's see. An atom contains equal number of protons and electrons. So you learned this in our previous lesson, that a single atom, it contains equal amounts of protons and equal amounts of electrons. So when it is equal, we say that it is electrically neutral. So we say that the atom is neutral. There's a balance. Right. So now, on the other hand, if an atom has an unequal number of protons and electrons, that means that they are not equal. Like, for example, if you hold, let's say, 5 marbles on your one hand, in your right hand, and those marbles could be your protons. And then if your left hand, you have 5 marbles, and you can say those marbles are your electrons. Now, if you take maybe if you take 2 of the marbles from your right hand and you put it into, you move it away, then you can see there's an unequal number of protons and electrons. Now this causes an imbalance. It's not equal anymore. Okay, so we say then the atom becomes charged. So when there is no balance of electrons and protons, there's an imbalance, then we say the atom gets a charge. And it no longer takes the form of an atom, so we don't refer it to an atom anymore. So we rather call it an ion. Okay, so it gets a new name when you say it is charged. So let's look at the definition of an ion here at the bottom on the right, on the left-hand corner. So an ion is an atom or a molecule with a net electric charge. So you say an ion is an atom or a molecule with a net electric charge due to the loss or gain of one or more electrons. Okay, so an ion has a net electric charge because an atom either has lost an electron or gained electrons. So any particle, whether an atom, a molecule, or an ion that contains less electrons than protons is said to be positively charged. So remember this, less electrons than protons means it is positively charged. And the opposite of the particles would be more electrons than protons, it would be negatively charged. So you can think of an easy way to remember it. So less electrons, so you can make up numerics like say LEP. LEP means less electrons positively charged. And then if we have MEN, so it would be MEN spells men. Okay, that would be an easy way for you to remember. So if you have men, it would be more electrons negatively charged. So if you remember men, more electrons negatively charged, then you obviously remember the LEP, less electrons positively charged. Okay, so that's one way of learning. Zamakule, I believe you have a question. My host will unmute you. Can you hear me? Okay, so my I'm going to continue until you get unmuted. So we say charged versus uncharged objects. So I put it in a table for you. So you have positively charged means possesses more protons than electrons. If it's negatively charged, it possesses more electrons than protons. And uncharged means that there is an equal number, there's a balance. So you have, for example, 5 marbles, which are 5 electrons on your right hand, equals 5 marbles, 5 protons in your left hand. So it's equal, it's balanced. So negatively charged, I'm going to go again slowly. Negatively charged means more electrons. So you see here, we have M, E, N. So more electrons means negatively charged. And then if we have, if it possesses more protons, okay, maybe that's an easier, MP, M. More protons means it is positively charged. So if it's more protons, it automatically means less electrons. So maybe this is really a better way. Helen, I believe you have a question.
Ma'am, can you hear me?
Yes, I can.
Ma'am, I want to ask, so if like positively charged, like is it like randomly a place that like the atom gets positively charged, or it's just like in certain places there's like positively charged?
So it
Like,
depends on also, like, you know, we learned solids, liquids, and gases and all of that as well. So it depends on the space of the contact between it, because it's static electricity, remember, that we're talking about here. So it depends how much of electrons transferred. It won't be constant all the time. So it can be random, as you said. So it, like when you push with brushing your comb with your hair. So the amount of electrons that actually got transferred would so it is random. You're right. You're correct. Okay. Does
thank you, ma'am.
that answer your question?
Yes, ma'am. Thank you, ma'am.
You're most welcome. Okay. So just to recap, MEN, more electrons, negatively charged. MP, PMP, more protons, positively charged. Or maybe you could say MP squared. Maybe that is better. MP squared, more protons, positively charged. So, you know, sometimes when you're writing a test and if you can't remember it, then you just write these things down on your working out paper, on your exam paper. So as you're answering questions, then you can just refresh your memory because you already know your mnemonics, and so you won't forget or you don't make a mistake, because sometimes when you're writing exams, you tend to get stressed. Okay, so let's talk about sparks and shocks. So now, before we go on to, I just want to explain what flammable substances are. So flammable substances are basically those gases or liquids or solids that can ignite. Ignite means that it can catch fire and it can continue to burn in air if it's exposed to a source of ignition. So like, for example, if you're at a gas station and if you see somebody smoking, and you're not really supposed to be smoking because it's bad for your health, but if you see somebody smoking and that cigarette goes close to the petrol, then it can actually cause an explosion. So you're not really supposed to, even if you see people smoking at gas stations, you should tell them they should not, because it's a source that causes ignition. Nanchlanchla, you had your hand up. My host, hi.
I want to ask, ma'am, if the smoke, ma'am, from those cigarettes can make the gas station explode, ma'am, how do the particles of that go into the oil?
So it's not really the smoke that's causing the this thing. It's the, you know, on the cigarette you see the fire.
Yes, ma'am.
When it is that one, that if you had to drop that onto the petrol, then because that fire would burn the petrol and it will cause an explosion. So that
Oh,
it's not really the smoke. Okay. Hi. Are you okay with that?
yes, ma'am.
Okay, so I'm going to continue. So we say sparks can be harmless, but they can also be very dangerous. So sparks can cause flammable materials to ignite. So we say, and I'm going to explain it to you here, the example that I used here, how it would work. So you will probably have noticed that you may not smoke cigarettes near an open flammable near petrol station. So you are actually not allowed to smoke cigarettes near a petrol station. And this is because the petrol fumes are very explosive and you only need a small amount of heat that can start them burning. So that heat that is in the cigarette can that small amount of heat can actually, and if it mixes with the petrol fumes, it can cause an explosion. So we say petrol is very, very flammable. Okay, it can burn very easily. It's one of the properties of petrol. So a small electrostatic spark is small enough to ignite flammable petrol fumes. So this is a very small electrostatic spark. So can you see how dangerous certain things are in real life when you put it into practice? So we have to be very careful with sparks and petrol when we're handling things that are flammable. We have to take great care when we're handling those things. So electrostatic discharge can also cause electric shocks. So electric shock is basically an upsetting or unpleasant event. So this causes this electrostatic discharge. It causes a shock. Now we're talking about on you being a person. Okay. So if you had to experience an electrostatic discharge, that means that you would get a small shock. And I'm sure some of you would have experienced it either going shopping when you pushed a trolley or when you went on the elevator, because I know I have experienced that. And then, so okay, have you ever been shocked with a shopping trolley or while you were pushing it around, or if you walked onto a carpeted room and then shocked yourself by touching the door handle when you leave the room? So this means that you experienced an electric discharge. So when you experience that electric shock, it means that you experienced an electric discharge. That means some of your electrons had moved away. That's on you. Okay, so electrons move from the door handle onto your skin. Sorry, it is the electrons from the door handle actually moved onto your skin. Now, because those electrons from the door handle came onto your skin, this movement of the electrons caused a small shock. So I'm going to repeat that. So the electrons from the door handle, when you touched it, basically, it moved onto your skin. And now because it moved onto your skin, it caused a small electric shock. Okay, so small electric shocks can be uncomfortable, but most of the time they are harmless. Now we have very large electric shocks, and that is extremely dangerous and it can cause injury and death. Does anybody want to guess what a large electric shock is before I move on to the next slide? You can pick Anshla. Or
Ma'am, a large electric shock is, I think, ma'am, it's a like, ma'am, it's dangerous to us because I don't know how to explain it, ma'am.
okay, no problem. Maybe somebody else can help you. Anybody else wants to help her? The host will unmute someone. Okay, so we say a large electric shocks are extremely dangerous and it can cause injury. So this large electric shock is Can you guess now? It's lightning. So the discharge of electrons from charged objects, yes, Helen, you have a question? Okay, so we say the discharge of electrons from charged objects happens more easily when the air is dry. So you need to know that it doesn't happen all the time, but it happens when the air is dry. So electrons become discharged mostly when the air is dry, which is why you experience electrostatic shocks and electrostatic sparks when the air is dry. Now, this is because when weather is humid, like in Durban, where the weather is humid because you're close to the sea, there's moisture in the air. So this moisture on the air collects on objects and it prevents the build-up of electric charges. So we say that the moisture in the air, it coats your surfaces and it prevents a buildup of electric charges, and then the charge dissipates through the moisture. So basically in humid climates like where you're close to the sea, there's a less likely chance of you getting electrically shocked or experience an electrostatic spark. So did you know where else the spark you can experience? So now if you looked at the photograph, you already have the clue. And it is a huge, lightning is a huge electrostatic discharge. So lightning is a huge electrostatic discharge. Now I'm going to explain how that works. So during a thunderstorm, there is friction in the atmosphere between the particles that make up clouds. So basically, in the atmosphere, when you have the clouds, they are next to each other, and if they rub against each other, it causes friction. So it's a build up of regions of charges. Now, once the difference in charges between the two regions become great enough, that means that it is rubbing next to each other, and the charges are moving from one cloud to another, and it's so significantly great, then it causes an electrostatic discharge. Okay, and that is where you see a huge lightning discharge. You see a huge flash. And this would occur in the regions between the clouds. Okay, so now we're going to move on to earthing. I'm going to explain what earthing is. So in order to discharge extra electrons safely from an object, we must earth it. So we say earthing basically means that we connect the charged objects to the ground. So earthing means to connect the charged objects to the ground, the earth, with an electrical conductor. Kalian, you have a question? Can my host unmute Kalian?
Ma'am,
I can hear you soft, you a bit soft.
earthing is used to stop the lightning from striking like your house and stuff.
No, sweetie, I didn't hear what you said.
Ma'am, is earthing also used to stop the lightning from striking close to your house?
Okay, earthing basically means that um, it prevents the discharge. So earthing basically, there's nothing that you can do that can prevent the lightning from striking, because lightning strikes anywhere. But you can take measures like earthing, like objects. You can earth certain objects, like when you have your thing, your electrical equipment, like your TV and your decoder. Now they have certain adapters in them, and these adapters basically earth your electrical devices that prevents lightning from affecting it. So you can earth certain things. You are correct by saying that. but not every. I'm going to explain what earthing means, and then you can understand better. Okay. So earthing means that we connect a charged object to the ground like an electrical conductor. Okay, the extra electrons travel along the conductor. So basically, you can earth yourself by having an electrical conductor, or rather earth objects, and enter the ground, which doesn't cause any harm. Now, you must know that the Earth's surface, because it is so large, it can absorb any extra charges with not any effect at all. So you don't have any effect. So, for example, think of the metal trolleys in shopping centers. Have you ever noticed that they normally have a metal chain hanging at the bottom which drags on the floor? So some trolleys, you would notice that they have a metal chain, and this would be more in drier regions because the air is dry. And and um, this is to earth the trolley to get a charge so that the charge cannot build up on the trolley. So the trolley, the fact that the uh, a little metal object is running on the floor, so it's giving off the charges into the ground, and it prevents you from getting shocked when you are pushing the trolley. So it protects you from getting shocked when you're pushing the trolley, because those charges are going into the ground with that metal piece that's going onto the ground. So basically, the earth is absorbing um, the extra electrons that move around. Okay, so that would be how things are earth. Now, the earth's surface obviously helps you to absorb electrons, and it protects you from the electrical charges. So we're going to move on to electroscope. So now these are pictures of an electroscope. If you look at it before I explain what it is. So on the left-hand side, you can see one that's used in a laboratory. Then in the middle, you'll see an ancient one that has a gold strip at the bottom. And we see another one here is an example with the disc at the top and two gold strips at the bottom. Now, the reason why they use gold strips, because you could say that gold is a very dense um, object, but you must also know that gold can be uh, made into very thin, fine, light, light as mean not heavy, light leaves. So this is why they use the gold strips, because it's very thin, and which is what you need in the electroscope. So the electroscope is in an early scientific instrument is used to find out the presence of charged objects. Please excuse me today, I'm not sure what happened. Okay, so the presence of charged objects, or it can be used to identify the type of charged objects. So in the electroscope, you're basically finding out about charged objects, the presence of charged objects, and the type of object that type of charge. So an electroscope is basically used to detect and measure electricity. So in the test, if they ask you, what is the purpose of an electroscope? You're going to say, it is used to detect and measure electricity. Then you could say it identifies the presence of a charged object, and it also identifies the type of the charge. Okay, so that's much better than my earlier explanation. So an electroscope is used to detect and measure electricity. It identifies the presence of a charged object, and it also identifies the type of the charge. Okay, so the electroscope is made up of an earth metal box with glass windows. So can you see that even in the modern day one, you have glass windows, and in the olden day ones, you also have glass windows. So there is a metal rod hanging down at the end with two strips of gold foil attached to it. So can you see here in each one, modern and old, you have a metal strip hanging down. Now, a disc or ball is attached to the top of the metal rod. So we have a disc here or a ball. So you can see here in the old one, there's a disc, here's a ball, and here's a disc. So it's attached to the top. And when the metal balls or the disc at the top are touched, at the top is touched with a charged object, like for example, if you knock something against it, and that then like if you bang something on the ball or tap something on the ball, or if you tap something on the disc, then the object is brought near, then the gold foil strips spread apart. So can you see here in the middle one? So now these gold foils, they strip apart. So if you had to basically bang something or tap something against this ball, these gold strips split apart. And can you see there's this, like a ruler here in the center one? So this ruler here, the one gold strip is measuring the charges. So now the more that you, or the harder that you probably bang it, then the more electrons that are being displaced, and then you can measure the charge of the object using this electroscope. Okay, so this middle one here is quite clear for you to see because it actually has the measurements here, and you'll understand how the electrons are measured. The charge is measured. So what you can do is you can make up your own electroscope at home. So what you would need basically is a glass jar with a lid. Okay, you need maybe some copper wire, about 12 centimeters in length. Okay, and then you need a 14-inch copper wire, which is 12 centimeter in length. Then you would need a plastic straw or plastic tubing. So plastic straw or plastic tubing. You need two small pieces of aluminium foil. So you know foil is very, very light. So instead of using the gold, because gold is expensive and it's hard to find, then you're going to use aluminium foil. Okay, then you would need a piece of wool cloth, you need a plastic ruler, and you would need a glass rod. Right, so let's see the instructions of how you're going to make it. So you're going to twist one end of copper wire into a spiral shape, and this will increase its surface area. So you're going to, normally when you see your parents or an electrician and they cut out the wire, they normally twist all the copper wire pieces around to make a spiral shape. So this basically makes it more, it gives it more, how do I say? It makes it more solid in a way that it's more concrete. Okay. So you make a hole on the glass jar and you push a small piece of the plastic tubing through the hole. So, and then you're going to put the other end of the copper wire through a small straw so that the spiral end is on the outside of the lid. Okay, so we're going to make a hook. John, you have your hand up. You want to ask a question?
Ma'am,
Yes. I can't hear you.
isn't 12 inches 30 centimeters?
If you confirm, if you 12 inches is, yeah, but here you're going to use 12 centimeters. Normally an inch is 1.5 centimeters. 1 centimeter to an inch is 1 centimeter is equal to 1.5 centimeters. So it's roughly around there. So if you use your calculator, one times, sorry. So 1.5
because you said
14.
because you
continue?
Now you can continue.
Okay, no problem. So you need 12 centimeters in length. Okay, I'm going to continue. I'll start from point 3. Okay, so you're going to put the other end of the copper wire through the straw so that the spiral end is on the outside of the lid. And you're going to make a hook out of the pointed end of the copper wire. So you're going to make that spiral end, you're going to make it like turn it into a hook. And you're going to cut 2 rectangular strips of aluminum foil. So your aluminum foil would be 2 rectangular strips. Now don't cut very, very big rectangular strips. You need to cut small ones like you saw in this picture here. You can see that these strips are small. Okay. And then now put each piece of the aluminum foil on the hook and make a small hook on the aluminum, a hole in the aluminum foil to allow it to hang in the hook. Sama Kushler, your hand is up. You have a question?
Ma'am, is it really must that we must make this electroscope?
Well, basically, you don't have to make it, but you can if you want to. It's just
Oh, okay. Thank you, ma'am.
You're most welcome. You can if you want to, because there's lots of scientists probably on the chat, I hope, that would benefit from making this because it would give you the experience if you'd want science to take up science in your field. And also because you're on lockdown, it would give you something to develop your curiosity about, because maybe through experimentation you can find other things. And basically our future scientists are you, if you're interested in science, because you would develop that knowledge and you develop that curiosity through experimentation, and one day you would be able to invent and develop new things. Okay, so all you young kids that are here learning are basically our future generation. So we're here to teach you all these stuff, and you're welcome to conduct the experiment. So now carefully put the hook end on the copper wire into the glass jar and then close the glass jar. Now remember that the lid has a hole so that the wire can go through. Now rub the ruler with a cool cloth for a minute. So you're going to rub the ruler, your cloth must be cool, and then bring the ruler closer to the spiral end of the copper wire. And then you'll notice you must notice what happens to the aluminum foil. If you bring it after you rub the ruler with the wool, then bring it close to the spiral end of the copper wire and then see what happens to the aluminum foil. Okay, so basically we say objects are neutral because they have a small number of positive and negative charges. Then objects can become negatively or positively charged when friction, when you're applying friction, which means rubbing, in the transfer between the electrons. Now, protons and neutrons cannot be transferred. Remember that I told you yesterday, the protons and the neutrons are in the nucleus and it cannot be transferred. It is only the electrons that are transferred by friction. So, Ramu, you have your hands raised. My host will unmute you. I heard a noise.
Ma'am, is it possible for a person to make an electroscope without one of the materials?
No, you would need to have all the materials or you could substitute one of the materials for something similar to the materials I showed you, because like if you're baking a cake and if you don't have, for example, butter, then you can change the recipe around and then you can use oil. But if you don't have butter or oil, then you can't make a cake. So you need the materials to make the electroscope. Does that answer your question?
Yes, ma'am.
Okay. So we say that Ramu, you have a question?
Ma'am,
Yes.
I just want to know what are all the materials needed to make the electroscope?
Okay, so I'm going to
I
go
missed
back
that
to
part.
it. I'm going to go back to the slide. So you basically need a glass jar with a lid. Okay, so if you finished peanut butter or Nutella, so you need your glass jar with your lid. So you would need a 12 centimeter copper wire. Okay, then you would need plastic straw or a plastic tubing. If you don't have plastic straw, you need plastic tubing. Then you need 2 pieces of aluminium foil. Does not have to be very big pieces, 2 pieces of aluminium foil. And you need a piece of wool cloth. Okay, so maybe if you don't have a piece of wool cloth, then you can use a wool jersey or something. Don't go cutting up your jersey now. You can just use the jersey. And then you need a plastic ruler and a glass rod. That's what you would need. So I think the glass rod would pose as a problem for you right now. But you can take it down and then you can conduct it when you get a chance. Okay, so just to go back the slide, this is basically if you, let's look at the one on the left. So let's improvise here. So this glass would be your glass jar. So this rod here would be uh, this here would be your aluminium foil attached to your copper wire, and then your rod would go up, and then you would need a top part here to the lid. You need the lid to cover the glass jar, and then you'd have that top part. Okay, so let me finish this. So if an object has more electrons than protons, it is negatively charged. So if an object has fewer electrons than protons, it is positively charged. So like charges, we say they repel each other, and they are negative. That means negative repels negative and positive repels positive. So negative charge repels negative charges and positive charges repels positive charges. And we say opposite charges attract each other. So a negative attracts a positive charge and a positive charge attracts a negative charge. So a discharge of the electrons from a charged object can cause sparks or shocks of static electricity, especially when the air is dry. So when the air is dry, it causes a discharge of electrons. And this discharge of electrons basically causes a spark or a shock of static electricity. So to recap everything that I said using this concept map or your mind map, we say static electricity results from friction. Friction is caused by rubbing. Friction transfers electrons and it does not transfer protons. Then it transfers electrons between atoms and it resulting in the surface of one material becoming positively charged, and it results in the surface of another material becoming negatively charged. So we have positive charges and negative charges basically attract each other, and this is due to a gain or a loss of electrons. So here we have friction between materials that could also be at 2 or more atoms. So we have the materials have materials with like charges repel, and materials with opposite charges attract each other. So that's basically static electricity and shocks and everything that you need to know about static electricity. And what we would be doing tomorrow, okay, is we're going to start with the transfer of energy transfer in an electric system. Then we're going to talk about circuits and current electricity and the components of a circuit. So here's good sites for you to see. Now, all the information is derived from CUVLA's website, and the Department of Education uses this as their natural science workbook. So a good site showing you the dangers of static electricity in a gas station. So if you want to see how it can actually ignite, you can visit this YouTube address here. And then if you want to learn how to survive a lightning strike, because that was one of the questions that one of the learners had, how can you survive a lightning strike? You can watch this video here. And if you want to learn more about making an electroscope, to give you an idea of how to make it, because I know some of you took down the materials, then you can watch this video here, and it will give you detailed ideas of how to make the electroscope. And give you, so if you want to contact me, my email address is ahaffea@gmail.com. And I will put up that website address in case you want to take it down. Kayleen, your hand is raised. Okay, so it's been a pleasure tutoring you. Thank you so much for joining the lesson. I hope you did enjoy it. And I'll see you tomorrow in our new lesson. Have a wonderful day. Enjoy exploring and learning. And see you tomorrow. Goodbye.